2, palma da mão. Quem cultiva a semente do amor, segue em frente, não se apavora. Se na vida encontrar de sabor, vai saber esperar sua hora.
Quem cultiva a semente do amor, segue em frente, não se apavora. Se na vida encontrar de sabor, vai saber esperar sua hora.
Às vezes a felicidade demora a chegar. Aí é que a gente não pode deixar de sonhar. Guerreiro não foge da luta, nem pode correr. Ninguém vai poder atrasar quem nasceu pra vencer. É dia de sol, mas o tempo pode fechar. A chuva só vem quando tem que molhar.
Na vida precisa aprender, se corre.
É Deus quem aponta a estrela que tem que brilhar. Ergue essa cabeça, mete o pé e vai na fé. Manda essa tristeza embora. Pode acreditar, um novo dia vai raiar. Sua hora vai chegar. Às vezes a felicidade demora a chegar. Aí é que a gente não pode deixar de sonhar. Guerreiro não foge da luta, nem pode correr. Ninguém vai poder atrasar quem nasceu pra vencer. É dia de sol, mas o tempo pode fechar. A chuva só vem quando tem que molhar.
Na vida precisa aprender, se corre,
É Deus quem aponta a estrela que tem que brilhar. Ergue essa cabeça, mete o pé e vai na fé. Manda essa tristeza embora. Pode acreditar, um novo dia vai raiar. Sua hora vai chegar. Ergue essa cabeça, mete o pé e vai na fé. Manda essa tristeza embora. Pode acreditar, um novo dia vai raiar. Sua hora vai chegar. Sua hora vai chegar. Sua hora vai chegar. Ergue essa cabeça, mete o pé e vai na fé. Manda essa tristeza embora. Pode acreditar.
Senhoras e senhores, bom dia. A Universidade do Vale do Itajaí tem a honra de iniciar o ScienceDay. Sejam bem-vindos, sintam-se acolhidos por todos os envolvidos na organização deste grande evento. O ScienceDay é um evento que tem como objetivo promover a interação científica transnacional entre pesquisadores de universidades e parceiros do ecossistema internacional, visando a divulgação e expansão do processo de inovação e geração de conhecimento, o fortalecimento da cooperação científica internacional e a busca comum de solução de problemas entre países. É uma ocasião em que os pesquisadores, professores, alunos de pós-graduação, bem como outros interessados, se reúnem para estabelecer contatos e trocar ideias em diversas áreas de investigação. Durante o evento, são debatidos temas de interesse tanto para a sociedade quanto para a ciência. Na quinta edição, o ScienceDay Ciência Sem Limite mantém a abordagem internacional e o formato híbrido, com atividades remotas no período da manhã e presenciais à tarde. Este evento busca atrair pesquisadores de várias partes do mundo para promover a integração entre os grupos de pesquisa e reforçar a cooperação científica internacional. Nessa perspectiva, a programação contempla um conjunto de palestras, reuniões científicas paralelas, discussões e sessões de pôsteres em um ambiente descontraído e propício para troca de conhecimento, experiências e colaboração em pesquisas de ponta. Agradecemos a participação de todas as autoridades presentes nesta abertura e destacamos a presença do magnífico reitor da Univale, professor Dr. Valdir Sequinel Filho, e do nosso excelentíssimo vice-presidente da Fundação Univale, excelentíssimo vice-reitor de pesquisa, pós-graduação e extensão da Univale, professor Dr. Rogério Corrêa. Agradecemos a presença das demais autoridades, palestrantes, professores, coordenadores, pesquisadores e a todos os participantes. O evento conta com o apoio do Conselho Nacional de Desenvolvimento Científico e Tecnológico, CNPq, e a participação de pesquisadores de universidades estrangeiras parceiras da Univale, de países como a República Democrática do Congo, os Estados Unidos, Portugal, Singapura, Canadá, Colômbia, Turquia e Reino Unido. Senhoras e senhores, convidamos para seu pronunciamento o magnífico reitor da Univale, professor Dr. Valdir Sequinel Filho.
Senhoras e senhores, muito bom dia, muito obrigado a todos pela participação. Quero saudar o nosso querido vice-reitor e vice-presidente da Fundação, professor Dr. Rogério Corrêa, em seu nome, saudar todas as autoridades, todos os presentes, de forma muito especial. Quero saudar e agradecer os nossos palestrantes nacionais e internacionais, em nome do professor Loyd e Bastin, dos Estados Unidos, do professor Kalunga, da República do Congo, e do professor Vladimiro Miranda, palestrante da Universidade do Porto, Portugal, que está nos acompanhando nesse momento e que participará à tarde com uma palestra. Muito bom revê-los a todos, mesmo que à distância. E que imensa alegria iniciar um novo mês, abrindo a 5ª edição de um evento que se consolida cada vez mais no calendário acadêmico da Universidade do Vale do Itajaí. Justamente validar uma das suas principais missões, ser útil à sociedade por meio do conhecimento científico. O ScienceDay nasceu da ideia de permitir que os resultados das pesquisas científicas reverberassem para além dos nossos muros, bem como de propiciar a conexão entre os pesquisadores e as diferentes áreas de conhecimento. Afinal, sabemos que a ciência não se faz só e que pouco resultado teremos ao divulgá-la apenas para os nossos pares. Ao ampliarmos o olhar para o universo, que está sempre em transformação, vemos cada vez mais a importância de uma ciência engajadora, ciência inovadora e compartilhada. Com a proposta de falar de ciência sem limites, o ScienceDay fortalece ainda a inserção da universidade na comunidade e amplifica a imensa relevância da pesquisa científica e de seus potenciais reflexos sociais. É um evento que ganha força a cada edição por congregar novas áreas e abrir espaços também ao empreendedorismo, à sustentabilidade e internacionalização. Ao receber pesquisadores de universidades estrangeiras, muitas das quais temos convênios de mobilidade e dupla titulação, o ScienceDay aumenta, e muito, o conjunto de oportunidades a que se propõe. Portanto, eu quero agradecer a todos os convidados, de forma especial, ao nosso querido reitor da Universidade de Kalamie, da República Democrática do Congo, o professor Victor Kalunga, e o professor da Widener University, Loyd Bastin, que gentilmente aceitaram o convite e irão compartilhar conosco os resultados de suas pesquisas e de suas experiências profissionais. Quero aproveitar aqui também para cumprimentar mais uma vez, o nosso vice-reitor de pesquisa, pós-graduação e extensão da Univale, o professor Rogério Corrêa, e a diretora de pesquisa em pós-graduação, professora Fátima Campos Uzi, e a todos os pesquisadores e colaboradores envolvidos na organização desse importante evento institucional. Espero que no período da tarde teremos uma vasta apresentação presencial na Beer House em Itajaí. Contamos com a presença de todos para tornar a 5ª edição do ScienceDay mais especial. Que possamos de inspiração para aguçar nossas próprias habilidades, buscar a energia muitas vezes perdida nas centenas de horas dedicadas à pesquisa e ampliarmos nosso repertório com a bagagem que só a cooperação científica é capaz de trazer. Finalizo desejando que todos desfrutem desta programação que foi preparada com muito carinho para romper fronteiras, expandir conexões e desenvolver projetos essenciais para a evolução de nossa sociedade. Um grande abraço, muito obrigado e um excelente evento a todos.
Agradecemos as palavras do nosso magnífico reitor. Dando prosseguimento, então, neste momento, daremos início à palestra Sustentabilidade Política e Econômica em Regiões em Desenvolvimento, com o magnífico reitor da Universidade de Kalamie, na República Democrática do Congo, professor Dr. Victor Kalunga Tshikala. Aos ouvintes, informamos que neste link a palestra será proferida em francês. Os links da apresentação transmitida com traduções para o português e inglês estão na página do evento e no chat. Neste momento, então, convidamos o palestrante para fazer uso da palavra e dar prosseguimento ao painel. Obrigada.
Je peux parler?
Yes. You can speak, Prof.
Bonjour à tout le monde. N'ayant pas une très bonne connaissance de la langue portugaise, je ne sais pas si vraiment c'est le moment pour moi de parler et si la technique peut m'aider un peu à comprendre à quel niveau de l'activité on en est pour que je sache comment intervenir. Merci beaucoup.
Good morning, Professor Victor. You can...
Morning. Merci. I'm okay. Thank you. I'm okay, but I don't know when are we now. If Miss Camila can help me to know what can I do now. I can pass to my presentation, or is it something I can say for this moment?
You can do your presentation. That's right.
Qu'est-ce que je fais?
Camila?
Eu estou atendendo aqui o telefone.
She's here. We are live, right?
Okay.
So yeah. I think you have a presentation. You can start it.
Okay, I can start it. Okay, thank you. My presentation, the version I have is in English, is in French. I can begin it in...
You can do it in French. That's all right.
Thank you very much. Thank you. Mesdames, Messieurs, bonjour à tout le monde. Ici, chez nous au Congo, à Kalamie, il est présentement 14 heures, donc 2 heures d'après-midi. Je crois qu'à Itajaï, on est encore en début de matinée. Je vous souhaite tous une excellente journée. Avant de commencer ma très brève présentation, je voudrais d'abord remercier les autorités de l'Université de la vallée de l'Itajaï, et particulièrement Monsieur le Recteur ainsi que tout ce staff qui ont pris la très bonne initiative d'organiser cette ScienceDay, la 5e édition, et de la remercier de pouvoir m'associer ainsi que d'associer tous les autres collègues. J'ai entendu ici qu'il y a les universitaires d'autres pays qui participent à cette importante activité. Cette activité qui est une opportunité qui nous est donnée à nous tous pour partager les vues, pour partager aussi les expériences, et ainsi nous pouvons apporter notre petite contribution aux efforts qui sont engagés partout au monde pour régler cette épineuse question d'une exploitation soutenable, durable, raisonnable, équilibrée et profitable à toutes les générations des ressources que nous avons encore sur Terre. Alors, je viens aujourd'hui pour ma présentation échanger avec les collègues qui sont avec moi, qui participent avec moi au cours de cette ScienceDay sur un problème qui concerne un peu le Congo, mais qui ressemble aussi à la situation dans la plupart des pays en développement. Alors, le devoir qui m'a été assigné, c'est échanger avec nous tous ici sur la thématique intitulée Soutenabilité et politique économique dans les régions en développement. Le cas du Congo-Kinshasa. Le Congo-Kinshasa, qu'on appelle de manière officielle République démocratique du Congo, est un État qui est situé au cœur du continent tel qu'on peut le voir sur la carte. C'est vraiment au cœur du continent africain, avec une superficie qui avoisine 2 400 000 km². À la dimension africaine, le Congo, c'est quand même un grand État parce que c'est le 2e État en termes de superficie ici en Afrique. Bien sûr, il n'y a pas de commune mesure avec le Grand Brésil avec ses 8 millions de kilomètres carrés et qui est l'un des 5 pays les plus vastes au monde. Mais lorsque on regarde la géographie de la République démocratique du Congo et on compare le Congo avec le Brésil, il y a beaucoup de choses qui se ressemblent sur le plan de la géographie physique de ces deux États. Comme le Brésil, le Congo est situé à cheval de l'équateur, donc des deux côtés de la ligne équatoriale qui sépare le globe terrestre. C'est ce qui fait que le fleuve Congo, un peu comme le grand fleuve, l'Amazone, a la chance d'être arrosé par les pluies durant toute l'année. Quand c'est la saison sèche, au sud, c'est la saison de pluie et il pleut, et c'est l'inverse lorsque au sud, c'est la saison sèche, au nord, c'est la saison de pluie. C'est ce qui fait que le Congo a quand même un débit très important. Il déverse dans l'océan Atlantique une très grande quantité d'eau. C'est ça qui fait d'ailleurs que le Congo est, en termes de puissance, en termes de débit, le deuxième fleuve le plus puissant au monde, après le grand fleuve Amazone qui se situe aussi au Brésil. Un autre trait qui rapproche le Congo du Brésil, c'est aussi la forêt. La forêt du bassin du Congo, c'est un peu plus de 3 millions de kilomètres carrés parce que cette forêt s'étend au-delà de la République démocratique du Congo. On en trouve une partie au Congo-Brazza, une partie en Centrafrique, même une partie à l'Est, comme au Rwanda, au Burundi. Et c'est un peu aussi comme la forêt de l'Amazonie. Et ce sont les deux grands bassins forestiers qui contribuent énormément au maintien des équilibres écologiques mondiaux. C'est ainsi que, au jour d'aujourd'hui, dans tous les efforts, dans toutes les discussions, dans les sommets qui se tiennent pour discuter sur les questions environnementales, le Brésil et le Congo passent pour les principaux pays solutions. Donc, entre le Brésil et le Congo, il y a beaucoup de choses en partage. Alors, sous le sous-sol du Congo, on trouve une grande variété de ressources minérales. En tout cas, depuis déjà le début de la colonisation, les explorateurs qui sont arrivés au Congo avaient fait un constat en disant que le Congo, c'est vraiment un scandale géologique. Et au jour d'aujourd'hui, on exploite en très grande quantité au Congo certains métaux, même des métaux rares, et même certains minéraux critiques tels que le cobalt, le lithium, le coltan et le cuivre. Et ces minéraux-là sont présents au Congo et le Congo en est l'un des principaux producteurs mondiaux. Conséquence, comme on le voit sur la carte ici, il y a un engouement terrible. Donc, les investisseurs viennent de partout pour chercher à exploiter les minéraux que l'on trouve au Congo. C'est vrai que d'emblée, ces minéraux, c'est quand même une très très bonne chose pour le pays, pour l'économie du pays, pour le bien-être de la population. C'est un espoir, mais parfois lorsqu'on regarde la situation au quotidien, au jour le jour, parfois c'est que les uns disent que les minéraux n'apportent pas que de bonnes choses. Oui, au Congo, on peut s'autoriser à un certain moment à dire que nous subissons la malédiction des ressources naturelles. Malheureusement, la malédiction. Parce que cet afflux d'investisseurs pour l'exploitation des minéraux au Congo vient faire une très grande pression sur les ressources naturelles. Et cette pression-là vient s'ajouter aux autres problèmes internes, aux autres problèmes propres au Congo. tels que une croissance démographique qui est vraiment effrénée. Et actuellement, le Congo, c'est le 15e pays le plus peuplé du monde. Ça, c'est les statistiques actuelles. Et les projections pour un futur très proche ne sont pas non plus très bonnes. Donc, cette croissance démographique ajoute une pression supplémentaire aux ressources naturelles en République démocratique du Congo. Et conséquence, c'est que ces facteurs-là génèrent d'autres problèmes, prédisposent les gestionnaires à des comportements qui ne sont pas de nature à assurer un bon développement. Il y a par exemple la question majeure de la corruption, bien sûr, qui n'est pas propre au Congo. On en trouve un peu partout au monde, mais quand même, il faut avoir l'honnêteté de reconnaître que actuellement le Congo figure sur une très bonne place sur la liste des pays dont l'indice de perception de la corruption est très élevé. Et à cela s'ajoutent d'autres problèmes propres au Congo, c'est l'insécurité. Au-delà des préoccupations d'ordre politique, les revendications d'ordre politique, mais la plupart des groupes armés qui opèrent au Congo n'ont pas du tout de finalité politique. C'est un peu des mouvements armés qui sont créés pour favoriser l'exploitation illicite des ressources naturelles. L'exploitation illicite des ressources naturelles. Et ça ne fait qu'aggraver les nombreux problèmes que nous avons en République démocratique du Congo. Et à cela s'ajoute maintenant le travail des enfants dans les mines, le travail des femmes dans les mines, alors que ce sont des catégories de personnes que l'on considère généralement comme étant des personnes vulnérables qui devraient être un peu écartées, éloignées des sites d'exploitation minière artisanale. C'est ce qui fait que depuis environ 20 ans, les dirigeants congolais ont pris quand même conscience qu'il faut mettre en place, qu'il faut réfléchir, mettre en place une qui permettrait de gérer, d'exploiter de manière plus ou moins rationnelle, de manière plus ou moins soutenable, le potentiel en ressources naturelles qu'on trouve sur le sol et dans les sous-sols de la République démocratique du Congo. C'est vrai que intégrer la soutenabilité dans les politiques publiques économiques, c'est une question qui soulève beaucoup de débats parce que il y a des fondements idéologiques, il y a les pressions des mouvements capitalistes qui font que parfois on essaie de banaliser la question, mais au-delà de toutes ces polémiques, la soutenabilité s'impose comme étant une nécessité vitale pour la survie des populations et pour le bien-être des générations qui vont nous succéder. On a intégré ce paradigme-là depuis un certain temps dans les lois économiques du pays. Alors, on peut en trouver des indicateurs, d'abord dans la Constitution. Déjà, la Constitution de la République démocratique du Congo et diverses lois de notre pays essayent de parler. Et lorsque on essaie de lire ces différentes lois, les principaux critères de la soutenabilité apparaissent dans les lois de notre pays. C'est notamment les exigences d'un développement économique et social durable, le maintien d'un environnement viable, une croissance équitable que l'on peut garantir à toute la population à partir des ressources financières qui sont générées par l'exploitation des ressources minérales. Il y a les exigences de la transition énergétique et écologique. Pour fonctionner les grandes usines d'exploitation minière, le besoin en énergie est très important. Parfois, les barrages hydroélectriques dont la construction a déjà un impact écologique important, mais ne sont pas toujours en mesure de couvrir ces besoins, ce qui fait que parfois, on recourt à l'énergie fossile par l'utilisation du charbon, que l'on extrait encore un peu au Congo, mais qui est importé dans les pays d'Afrique australe. Oui, tout le monde est conscient qu'avec les ressources naturelles du Congo, il faut mettre en place une exploitation qui permet un développement économique et social équitable et qui permet de garantir le maintien d'un environnement sain et durable. Alors, quand on lit la Constitution de la République démocratique du Congo, en son article 58, l'État congolais prend l'engagement de garantir à tous les Congolais le droit de jouir des richesses nationales. L'État prend l'engagement de redistribuer équitablement ces richesses nationales et de garantir à tout le monde le droit au développement. Il va de soi que cet engagement constitutionnel provient de nombreux instruments juridiques internationaux qui recommandent aux États d'intégrer la politique de sustentabilité dans leurs politiques internes. Alors, ces engagements-là sont traduits de manière assez spéciale, assez particulière, dans les différentes lois qui organisent l'exploitation des ressources naturelles. On en trouve dans le code minier, on en trouve dans le code forestier, on en trouve dans le code agricole, on en trouve dans certaines lois qui ont été adoptées un peu plus récemment, telles que le code de l'eau, le code d'électricité, le code de la loi sur la conservation de la nature, et même la loi sur les hydrocarbures. Donc, tous ces textes-là s'efforcent un peu d'intégrer les préoccupations de l'exploitation soutenable des ressources naturelles pour garantir un développement durable, équitable, équilibré à tout le monde. Ça, c'est vraiment un principe qu'on trouve dans nos lois. Mais plus intéressant encore, lorsqu'on lit la plupart de ces lois-là, en ce qui concerne le développement social, les lois congolaises intègrent les préoccupations relatives à la responsabilité sociétale des entreprises. C'est vrai que en 2000, au début des années 2000, lorsqu'on commençait à intégrer petit à petit les exigences de la responsabilité sociétale des entreprises, il y avait quand même des hésitations. C'était au départ une responsabilité molle, pas très dure. Mais à partir de 2015, toutes les lois qui ont été adoptées ont essayé de renforcer, de durcir un peu les obligations sociétales des entreprises qui opèrent dans le secteur des ressources naturelles. Au nombre de ces obligations, il y a par exemple l'obligation de réaliser une étude d'impact environnemental et social. Ça, c'est pour tout projet. Que ce soit un projet d'exploitation minière, que ce soit un projet pétrolier, que ce soit un projet de construction d'une grande usine, le promoteur du projet doit produire et soumettre, obtenir l'approbation de son étude d'impact environnemental et social. Il doit aussi produire un plan de gestion environnementale et sociale du projet qui contient toutes les stratégies qu'il veut mettre en place pour essayer de réduire l'impact environnemental de ses activités. La loi, particulièrement le code minier, quand il a été révisé en 2018, il y a eu une avancée significative en ce qui concerne la responsabilité environnementale. On a essayé d'intégrer de manière très claire le principe pollueur-payeur. Désormais, lorsque l'exploitation des ressources naturelles ou toute activité industrielle crée un dommage environnemental qui cause un préjudice aux personnes ou aux biens, l'auteur de ces dommages doit réparer, qu'il y ait faute ou pas. On a changé de paradigme. Avant, le principe, c'était que lorsqu'il y a un dommage environnemental, l'auteur de ces dommages ne pouvait réparer ces dommages que si il avait intégré cela dans son projet. Mais si c'est un dommage qui survient pour une circonstance qu'il ne pouvait pas envisager, eh bien, on ne pouvait pas le sanctionner pour ça, l'obliger à réparer. Mais ici, on a carrément posé le principe d'une responsabilité objective et sans faute. Alors, comme en ce qui concerne particulièrement les ressources minières qui, en principe, sont épuisables, on a créé un fonds minier pour les générations futures. Ce qui fait que dans les recettes qui proviennent de ces ressources-là, on met de côté un peu d'argent que l'on peut engager dans le développement des projets qui pourraient servir à l'avenir. Mais aussi, on demande aux opérateurs qui opèrent dans le secteur minier particulièrement de développer certains projets de développement au profit des communautés locales qui sont impactées directement par le projet. Par exemple, en construisant un hôpital, un centre de santé, une école, en aménageant un petit pont. C'est quand même quelques mesures qui ont été prises. Mais sur le plan du contenu local, des projets d'investissement, des grands projets d'investissement, les lois insistent sur la nécessité d'intégrer les nationaux dans les capitaux de ces sociétés-là. Donc, chaque fois que l'on crée une société au Congo, pour l'exploitation minière par exemple, à part l'investissement étranger, on doit laisser une petite place aux nationaux pour qu'ils puissent aussi participer au capital. Petit à petit, on peut créer une petite classe moyenne. Et c'est ça qui justifie aussi que on a institué l'exclusivité de la sous-traitance. Donc, quand un grand projet opère au Congo avec un investissement étranger, le marché de la sous-traitance est réservé exclusivement aux sociétés de droit congolais et qui sont contrôlées par les Congolais. Ça va de soi aussi que on doit privilégier l'embauche pour les contrats de travail, on doit privilégier le recrutement des nationaux pour travailler dans les entreprises, à moins que on n'ait pas une expertise locale par rapport au poste qui est offert. Dans ce cas-là, on peut recourir à la main-d'œuvre étrangère. Mais lorsqu'on prend d'un côté ces ressources naturelles, dont le potentiel est important, on prend de l'autre un très grand nombre d'investisseurs qui sont déjà opérationnels au Congo, mais quand on va sur le terrain, on constate que c'est vraiment un contraste. Un contraste, il n'y a pas du tout de corrélation entre le grand potentiel en ressources minières, en ressources forestières, en ressources en eau, en potentiel électrique. Lorsqu'on prend aussi le flux financier qui est en circulation au Congo, mais on compare avec le niveau de vie des populations. Vraiment, il n'y a pas de commune mesure. Au jour d'aujourd'hui, l'indice de développement humain au Congo est très, très, très bas. Le Congo est malheureusement compté parmi les pays les plus pauvres. Alors, cette situation de contradiction amène quand même tout le monde à se réfléchir, mais finalement, mais pourquoi ce contraste? Oui, ça c'est une question que l'on se pose en interne. Mais c'est à des occasions comme celle-ci, lors de cette ScienceDay, que nous, ici au Congo, qu'on peut en profiter pour vous partager cette expérience, cette triste réalité, peut-être pour savoir exactement comment, sous d'autres cieux, un peu comme au Brésil, et comme je l'ai dit en introduction de ma communication, que le Brésil présente beaucoup de similitudes avec la RDC sur le plan de la géographie physique. Mais au jour d'aujourd'hui, le Brésil se place quand même parmi les pays, en tout cas, certains disent simplement que c'est un pays émergent, mais c'est quand même un pays très développé. C'est devenu aujourd'hui une grande puissance économique, au même titre que l'Inde, au même titre que beaucoup d'autres pays d'Europe ou d'Asie. Mais alors, au Congo, on s'est dit, mais finalement, est-ce que peut-être on ne devrait pas voir ce qui s'est fait ailleurs pour essayer d'adapter, d'appliquer chez nous, afin de relever le défi de la pauvreté, le défi de la préservation des équilibres géologiques, mais aussi le défi, et globalement, d'un développement économique, social, équitable, qui profite à tout le monde. Voilà, monsieur le recteur, mesdames et messieurs, le peu que je pouvais partager avec vous dans le cadre de cette ScienceDay. Je vous dis grand merci. Je réitère encore toute ma reconnaissance à Univali qui a voulu que nous puissions participer à cette 5e édition de la ScienceDay. Merci.
Agradecemos ao palestrante, o magnífico reitor da Universidade de Kalamie, Dr. Victor Kalunga Tshikala. Dando prosseguimento, anunciamos nossa segunda palestra abordando questões de sustentabilidade utilizando a química verde. E convidamos o professor Dr. Loyd Bastin, da Widener University, para fazer uso da palavra e dar prosseguimento ao painel. Aos ouvintes, informamos que neste link a palestra será proferida em inglês. Os links da apresentação transmitida com tradução para o português está na página do evento e no chat. Com vocês, Dr. Loyd Bastin.
Good morning. I apologize for the technical problems. I very much appreciate the invitation to speak with you today. I am Loyd Bastin. I am a professor at Widener University in just outside of Philadelphia in the United States. So good morning from the States. I'm delighted to talk to you today about green chemistry and what green chemistry is, and how we can use green chemistry to address the pressing sustainability issues that we face as a planet today and in the future. Next slide, please. As I'm sure most of you are aware, sustainability is an issue that we are dealing with globally, and the United Nations has done a lot of work to bring us into thinking about the future without compromising has done a lot of work to encourage us to think about how to meet our present needs without compromising the ability of future generations to meet their own needs. They defined this back in the late 1980s, and much more recently, they have developed a set of sustainability of development goals. And I've highlighted here all of the 17 UN sustainability goals that I think green chemistry can help us meet. We use chemistry for a number of things around in our society. So if we can go to the next slide. Chemistry fuels everything that we do in society. Chemistry is at the heart of our pharmaceutical industry, our biotechnology. It's at the heart of our personal care products, our cleaning products, our food and beverage industry. Chemistry underlies all of these things: paints, coatings, electronics, automobiles, construction and building materials. Pretty much everything that we have in society revolves and is centered on chemistry. And so for me, if we're going to meet our sustainability goals and live sustainably, we have to think about the underlying chemistry that is part of everything we do on a daily basis. Next slide. And that chemistry has a lot of issues that have led to sustainability problems. So a lot of people think chemistry has caused many of our sustainability problems, and I think it probably has. But I hope I can convince you today that chemistry plays a key role in addressing these issues as we move forward. So when we think about the chemistry requires resources. We have to get chemicals from the environment. So if we're going to make plastics or pharmaceuticals or really anything that is carbon-based, right now, most of those chemicals, most of those products come from chemicals that are made from crude oil. And we obviously all know that we use crude oil for energy as well, but we're also using crude oil to make almost all of the chemicals that we use on a daily basis to make all the products that I mentioned previously. We also use a lot of metals in these products, and those metals are also extracted from the planet, much like crude oil. So we have to mine lithium and copper and cadmium and all of these metals that we use in our electronics. And all of this is being used. We're getting the source of all of these chemicals is an unsustainable source. We are using these resources much faster than the planet can regenerate them. Next slide, please. Once we have those resources, then we have to produce the chemicals and then use those chemicals to produce the product that we're looking for, that we want to produce. And that process, the production process, creates pollution. It creates air pollution. It creates waste that sometimes, well, let me take a step back. These production processes, the chemistry, the inherent chemistry produces waste that ends up either as air pollution, liquid waste that sometimes ends up in the environment accidentally. Many, 100 years ago, it was being put into our rivers and our streams as a waste product. So we're using processes that produce waste that we then have to release into the environment or capture in some way. And that has led to a lot of air pollution and water pollution. Next slide, please. And as I mentioned a little previously, all of this requires energy. So extracting the materials from the planet, producing the chemicals and then producing the products, all of this requires energy. And currently, most of our energy comes from petroleum and other fossil fuels. And so again, we're utilizing an unsustainable resource for the energy that we need to produce all of these products, compounding the problem of the use of fossil fuels. The number one and number two sources of our energy are non-renewable, non-sustainable fossil fuels in petroleum and natural gas, and the third one even coal as well, not sustainable. And so this is all compounding that problem. Next slide, please. And then once we make our product and we use the product, we have the issue of disposal. And this is where the next big problem comes from. And that is, how do we dispose of products when at end of life? Ideally, we would dispose of those products by maybe reusing them, recycling them. But unfortunately, in the United States, we recycle at very poor rates. Our plastic recycling rate is about 20%. And our electronic recycling is even lower than that. I think it's around 15%. So we have ideas of how to reduce our impact on the environment, but they're not being utilized because they're not cost effective. They're also highly energy intensive. Recycling, very energy intensive, whether you're recycling plastics or you're recycling metals. It's all very energy intensive. So then what do we do with these products? Well, they may be put into a landfill, or they may be incinerated, or they may be buried. That's what we hope happens to them currently, but a lot of times that doesn't even happen, and they end up as pollution in our environment. Hence our plastics waste, our microplastics. And so we now have this problem where we can't even get rid of all the products. We created products that had long lifetimes, which we thought was a great way to go, but we now can't get rid of those materials. And we are creating this waste and pollution that we have to deal with. Next slide, please. And then on top of that, this pollution, where the location of the resources, the extraction of the resources, and the effect that has on the environment, the production, where are we producing these products, and where is that pollution located, and then the disposal facilities are all disproportionately affecting people of color. In the United States, we refer to this as environmental injustice or environmental racism. This term was coined in the United States by a professor, Dr. Robert Bullard, who realized that in Houston, all of Houston's waste dumps, waste facilities, trash dumps were located in and around primarily African-American neighborhoods. We have another very famous example. We refer to it as Cancer Alley, which is in the state of Louisiana, near the Gulf of Mexico, and along the Mississippi River. There is, and it's highlighted in red and orange, and this picture in the bottom right corner, there is a disproportionate number of chemical companies located along the Mississippi River, and they are in neighborhoods that are predominantly Black, and they have extremely high rates of cancer in that area. This unfortunately is happening all over our country and all over the world. I am most familiar with the places in the United States, but it happens in almost every city, every state in our country. It is also happening in Africa, where you have waste facilities that are disproportionately affecting the poor and the poor in those countries. Next slide, please. This is particularly an important issue to me because I work in Chester, Pennsylvania, which is an environmental justice community. And I wanted to show this map just to show what I mean by this. This is a map of the waterfront in Chester, Pennsylvania. And you can see there is 7 facilities located in this very small area. This is maybe a quarter of a mile of a road, and it has a large paper manufacturing plant. It has the largest trash incinerator in the country located in this area. It has a water treatment plant that for the county in this area, and then it has 4 different chemical companies located in an industrial park there. These are large facilities creating quite a bit of pollution. And if you look at the next slide, please. If you look at the demographics of this area, this is a map that a student of mine created. On the left, you can see what the stars indicate the locations of those facilities I showed on the previous map. And the colors, the red indicates percentage of people of color. And you can see it's all red, which means it's 95 to 100% people of color living in that area. And if you then start looking at their health risk, the people living in those areas, and they live right across the street from these facilities, their rates of asthma are much, much higher. We've also done a number of air quality studies. A colleague of mine at Johns Hopkins University, Peter DiCarlo, has measured the air quality and the air pollutants in Chester. That work is not yet published, so I'm not able to present it here, but he has found a number of hazardous cancer-causing chemicals that are at much higher rates than the EPA and any air detecting system that's in the area is detecting. So he did real-time monitoring and found the levels to be much higher than you would expect or anyone anticipated. The next slide, please. So for me, in order to address these large-scale sustainability problems, we have to retrain much of how we think about chemistry and much about how we think about how products are produced, used, disposed of. And so we have to, as a chemist, I was trained to think about the chemistry, right? What happens in my lab? What happens in my flask? What happens in that plant when it goes up? I was not taught to think about the entire system, right? But as I hope that you're getting the sense of, chemistry is a much bigger system than the chemical reaction that's going on in your flask or in the plant. The system involves the raw materials. Where do they come from? Where are those raw materials located? How do they affect the communities around them? What does the manufacturing process look like? How much waste are we producing that we then must dispose of in some way, either through the smokestacks in the air or through waste that's either liquid or solid? What does that manufacturing process look like? What I haven't talked about yet is the packaging of your product. That also involves chemistry. Where do those raw materials come from? How far are you transporting them? What are they made of? What processes are being used to make those products? The distribution. How far are you distributing the product? What are the resources that are needed for that distribution? And then how are we using those products? We do think about that a lot, right? We want to make sure the product is safe for the consumer. We want to make sure it does its job and doesn't do have other side effects. And so we do think about that quite a bit in the pharmaceutical industry and in other consumer industries. And then this disposal that I have talked about already. What happens to the product at the end of life? And all of these pieces, we also have to think about where they are located, as I just mentioned. So not just the chemistry, we have to think about the entire system. Some people refer to this as systems thinking. Some people talk about it as life cycle analysis. Whatever we call it, we need to think in this bigger system and think about all the components that go in and how that affects our planet. Next slide, please. So that gets me to green chemistry. So green chemistry is a different way of thinking about how we approach chemistry. So in chemistry, we think a lot about risk, right? What is the risk of the chemicals that we are using, the risk of the chemicals that we are using, producing, and are they safe for the person working with those chemicals, the person using those chemicals, but also is it safe for the environment? And we have traditionally in the United States, and I think across the globe, reduced the risk both to the worker in the plant, the chemist in the lab. We have reduced that risk by reducing the exposure. We have safety protocols. We protect ourselves. We have environmental regulations that you can't just emit harmful chemicals into the air or dump chemicals into water. These all came about in the United States in the 1970s with a number of environmental protection acts. So we've always dealt with this by reducing that exposure. And then, if needed, sort of banning a chemical from being used. Green chemistry thinks about this differently. Green chemistry's goal is to reduce the hazard. So we won't have any risk if we're not using hazardous chemicals, if we're not generating lots of waste to dispose of. So sort of an inherent difference about how we think about our processes. So let's reduce the hazard of what we're producing, not the exposure to those hazardous chemicals. This idea was formulated about 26 years ago, a little bit longer than that, but the book that introduced the idea of green chemistry came out in 1998 and was authored by Paul Anastas and John Warner. And in that book, they laid out the framework by which we can change the way we do chemistry. And the thing that most people take away from that is they outlined 12 principles of green chemistry. And I've included them on the slide, and I'm not going to go through each one. They are sometimes, they're in chemistry terms, but essentially what the 12 principles do, it says we need to reduce the amount of waste that we produce. We need to reduce or eliminate, really, the use of hazardous chemicals. We have to think about the toxicology, the toxicity of our products. So we need to reduce the toxicity of any of our products. And we should get our chemicals and materials from renewable sources. So use safer chemicals, create less waste, use less energy, use renewable sources, and also design products that will biodegrade. Those are the 12 principles and maybe 6 principles. Next slide, please. So in my mind, green chemistry can address all of those issues, sustainability issues, and the environmental justice issue by thinking about if we develop biodegradable products that don't accumulate in nature, that reduces pollution from our disposal, right? It reduces the amount of waste that we have to deal with in landfills and incinerators. If we develop processes that generate less hazardous waste, again, we're reducing pollution during that production process, both air pollution and liquid and solid pollution. If we develop new processes and products that use starting materials that come from renewable resources, that reduces the extraction of natural resources from disadvantaged communities. And so for me, that's what green chemistry does. It inherently allows us to address these major sustainability issues that we are dealing with. There's a lot of talk a lot of talk now about a circular economy and actually using, if you can't reduce the waste that you're producing, if you're producing something that you don't need, how can we reuse that, right? A lot of people refer to this as a circular economy. So my waste might be your starting material in your process. And so I think layering green chemistry onto this circular economy, which really is a reuse, right? We have a saying here in the United States: reduce, reuse, recycle. And we've kind of forgotten the reduce and the reuse and been focused on recycling. But really, I think we need to refocus on reducing and reusing. And I think green chemistry helps us do that. Next slide, please. So I wanted to give you just a couple of examples of this. So I realize you probably do not have the Tide product in Brazil, but I think you'll get my point. I like this example because it shows the sort of stepwise improvements that you can make in how laundry detergents are made and used. So Tide in the United States used to be sold in a cardboard box, and it was a powder, and you would have to dissolve the powder in your washer, and it would not fully dissolve because it wasn't fully soluble in cold water for sure, and sometimes it wasn't fully soluble in hot water. And so you're wasting product because it wasn't completely soluble. It also created this film on the inside of the washing machine that you then had to use a chemical to clean. So you were not only wasting your product, you were also using another product to clean because it wasn't being efficiently used. And Procter & Gamble, which is the company that makes Tide here in the United States, recognized this problem, and they created a liquid detergent, which is probably their most common product now. And when they made that switch, they did have to go to plastic containers. At the time, we thought that that was good because we were using a lot of trees for the cardboard, and we thought plastic was a good solution. I think we now know that's not an ideal solution. But what moving to the plastic did was allow them to have this liquid detergent. And then the way they address the plastics use is they slowly, over time, are getting more and more concentrated solutions. And you can see there's a 2x on the picture in the bottom left that I have here. I think we're at 4x concentration now. So they get many more loads of laundry in the same size plastic container. The next innovation that they made is they realized, wow, we use a lot of energy when we wash our clothing in hot water. So they created what they called cold water tide that utilized, you could do all of your laundry in cold water, and it was equally effective in the washing process. They then moved, and they now have a product called Pure Clean, and Pure Clean addresses the renewable sources product. So Pure Clean Tide utilizes plant-based sources for the chemicals. So all the previous products, they used fossil fuels as the source of the chemicals that make up those products, make up the plastic. The Pure Clean uses all plant-based raw materials to make the detergent, to make the plastic container, etc. And they also got rid of cold water tide because all of their detergents can now be used in cold water. You do not need to wash the clothing in hot water at all. They also have created Tide Pods, which a lot of people in the United States use. These have a plastic container that dissolves and delivers the detergent in a smaller amount, so it uses less detergent, but it also, that plastic is dissolving and going into the water. So I assume that they are trying to think about biodegradable polymers for those pods. You might wonder, could we figure out how to not need to wash those clothing? What's the future of this, right? And where do we go with that? Next slide, please. I would also, I think, if we're going to, as we think about green chemistry and we think about these systems, we can learn a lot from nature. And so I put this example up because a company in Denmark, I believe it was, Aquaporin, developed a desalination technique based upon learning how nature naturally desalinates water. And they created a polymer layer using biological membranes rather than a fossil fuel based polymer made in the lab. Next slide, please. And then I want to go back. So John Warner, one of the founders of green chemistry, has created a number of companies as part of the Warner Babcock Institute for Green Chemistry, which was a pre-pandemic institute that he ran. He now has something called the Technology Greenhouse, and they do a lot of consulting with companies on how to improve their processes using green chemistry, and also have created a number of products and and startup companies based upon that technology. They have a technology for recycling ocean plastics. They have a technology for taking gray hair and returning it to its natural color. They have a technology to recycle asphalt, and they've created an Alzheimer's treatment that is in clinical trials, all using a green chemistry. So you can use green chemistry to improve products across many types of chemistry and industries. Next slide, please. So I thought I will end by just telling you a little bit about what my research group does at Widener utilizing green chemistry. So we take we work on, I'm an organic chemist, and we do organic synthesis, and we mainly focus on known pharmaceuticals or analogs of known pharmaceuticals, and we look at the traditional synthesis for those molecules, the traditional way that they're made, and we apply the green chemistry principles. We look at those procedures and processes. We analyze the starting materials, the reagents, the products, the byproducts, and we identify the hazards and the inefficiencies in those methods and modify the process, then either create a new pathway or process or improve that process. Then we test that process and we continue that loop until we think we have the best, greener alternative way of making that molecule. So next slide. We also utilize a lot of microwave chemistry. I'm a little short on time, so I'm going to just move past that. If you want to talk about microwave chemistry, I'm happy to do that. I'll talk about it a little bit later on another slide. Next slide, please. So one of the molecules that we are working on are a group of pharmaceuticals known as isoxazoles. They are this 5-membered ring that you see in the middle with the N and the O. That's a nitrogen and oxygen. That piece that's in the middle of both of these molecules has a biological activity. I'm sorry, hold on just a second. Sorry, I got it. So this 5-membered ring has the biological activity, and you can get different properties based upon the groups that are attached to that 5-membered ring. And so I've put 2 up here that are being used currently. The one's in clinical trials, and one is on the market as an anti-inflammatory. But based upon the groups that are attached to that key 5-membered ring, you can get antibacterial, antimicrobial, anti-tumor, or antifungal activity. And the synthesis of these molecules uses a lot of hazardous reagents and generates a significant amount of waste. And so we wanted to look at if we could address that, and could we produce a greener synthesis for these molecules. Next slide, please. So this is one of the traditional syntheses of isoxazoles. We have been focusing on diphenyl isoxazoles, specifically 3,5. So groups on the carbon next to the oxygen and groups on the carbon next to the nitrogen in that ring. And since this isn't a chemistry audience, I won't go through the details, but I've highlighted that there's a lot of carcinogenic materials being used in this synthesis. There's a lot of corrosive materials. There's a lot of volatile corrosive materials, and there was a lot of waste being generated in this synthesis. So we looked at that, and we looked what changes can we make to address those issues. Next slide, please. So we created this synthesis over the last few years. I've had a number of students who work on this, and we actually ended up starting in a different place. So we eliminated that carcinogenic starting material, replaced it with something that's much less hazardous. Then we utilized bleach to do that first step, so household bleach. And then In the second step, we have done a few things. We have significantly reduced the amount of waste generated, mainly not through the chemistry, but through what you needed to do to isolate your product. We changed that method and we reduced the waste by an order of magnitude. We then, in the third step, have gotten rid of pretty much all. We've gotten rid of 2 of the hazardous chemicals there. We use sodium bromide, which is not hazardous at all unless you ingest a very large amount of it. We do still have an oxidizer there, and oxidizers by their nature are a little bit hazardous. We have reduced the hazards of the oxidizer, and we have changed the solvent to be a solvent that's actually derived from renewable resources and less hazardous than the previous solvent. We've also done 2 of the 4 steps in the microwave. So we have a room temperature or a reflux version of the reaction. We also have a microwave version of the reaction. And we have done this reaction on about 15 different analogs of these molecules, and it works quite nicely. Next slide, please. The other molecules that we work on are called malilamides, and these are also molecules that have, they're not as well studied, but they are believed to have some pharmaceutical activity and may have some activity in treating Alzheimer's. They are also used as herbicides, and so or herbicide safeners. So we wanted to look at a synthesis that was environmentally friendly and green. Next slide, please. So in collaboration with a colleague of mine at a different institution in Pennsylvania, we developed this synthesis here. She developed the reflux, the thermal heating method, and we developed the microwave version. And I won't go through the details of the synthesis, but it is it uses very little solvent, it generates very little waste, and we also have measured the energy efficiency, and the microwave is 41 times more efficient in the second step of this process, and 5 times more efficient in the third and final step. Next slide, please. We have also done a little bit of microbial testing on these. These molecules are not as well known, and so we have tested for microbial testing with E. coli, and we do see some activity for the product, the second product in this step. We don't really see much activity for the product of the third step, but the product of the second step does seem to have some microbial properties, and we have some promising results, but we're not microbiologists, so we are looking for people, for collaborators to sort of help us with this work. I'm actually going to skip the next 2 slides if I could. So I just wanted to finish by saying that at Widener, we have been doing green chemistry since 2007. We teach all of our students about green chemistry, and we have a lot of green research projects going on. There's another organic chemist that does organic synthesis of pharmaceuticals as well, but we have faculty working on metal organic frameworks and using a microwave as a greener way of making those metal organic frameworks. So we have a lot of work going on with microwave, and one of our P chemists also studies the thermophysical properties of ionic liquids, which show some promise as alternative solvents to organics. And then the next slide, please. And then I wanted to highlight that we also think about sustainability in how we do our chemistry at Widener. So we have replaced all of our exhaust hoods that pulled the air out of the room. and out the roof to keep people safe from their chemicals, and we replace them with these recirculating air. So they just recirculate the air in the hoods, and this reduces our CO2 production by 1 million pounds a year. We also utilize waterless condensers when we thermally heat. So we've reduced our water use by probably 150 gallons a year. Probably saves us about $100,000 a year. The hoods save us about $60,000 a year. And so we really think about how we can improve our processes, not just our chemistry. And I also mentioned that we're trying to reuse and recirculate all the water that we use, and also use the microwave as much as we can. So my final slide, please. I just want to acknowledge that I have an amazing group of students that have worked with me over the last few years. Their names are all here. I have some amazing collaborators at Widener and other institutions. And I have gotten some funding from both Widener and the American Chemical Society here in the United States. And then next slide. And I just want to thank you for the invitation to speak, and I'm happy to answer any questions. A comment popped up on my screen that the cosmetic industry represents a great opportunity, and I would agree 100%. They definitely need to be pressured with regulations. I didn't talk about this, but I also work a lot with my students in the classroom to look at policy and to apply green chemistry to policy and lobby our representatives to increase regulations, but also to encourage companies to use green chemistry and sustainability in their processes.
Acredito, então, que não tenhamos perguntas, pelo que a gente está vendo aqui no chat. Não sei, deixa eu ver. Não. Apenas agradecimentos, então. Nós agradecemos ao palestrante, o professor Dr. Loyd, da Widener University. Thank you. A partir deste momento, então, iniciaremos as reuniões científicas paralelas por área de pesquisa. Os participantes podem selecionar a área de interesse e acessar as salas cujos endereços constam no site do evento e no chat. Aproveitamos, então, para convidar todos e todas para retornarem às atividades no período da tarde, que será em formato presencial na Beer House, localizada na rua Lauro Miller, número 1219, na cidade de Itajaí, a partir das 14 horas. Até mais e um bom dia para todos.